Hi everyone, welcome to Unit 3, Lesson 2, Product Rules of Exponents. Okay, so first off, let's just go over some of the basics about exponents. Hopefully you've reviewed it a little bit before now. If not, that's okay. So we have some key words, and these are brought up and defined in your lesson, so make sure to look at those and write them down. But one of them is base. And in this number setup over here, this is the base. Okay? So, the base. Alright? Is the 2. The number that is being taken to an exponent is your base. Alright? That's the number that you know to multiply by itself, however many times the exponent tells you to. The exponent, or the power, that's this guy here, the little number. Okay? So 2 to the third power. You might hear that, right? Or 2 cubed, in this case, when you multiply, or when you use a 3 as your exponent, you're cubing it. Okay? And that comes from finding, like, the volume of a cube. You multiply length times width times height, which are all the same number, right, with a cube. But anyway, that's known as the exponent, or when we talk about them, we refer to them as a power. Okay? So, an integer, you know what an integer is. It's just positive and negative numbers and 0. And then product, that's the answer to a multiplication problem. Hopefully that's somewhere in the back of your brain even from a long time ago. So if I were to evaluate this would tell me, one, the 2, or the base, tells me what I'm multiplying, and the exponent tells me how many of them to multiply. So in this case, 2 to the third power is 2 times 2 times 2. Well, I could even keep going. 2 times 2 is 4, times 2 is 8. So 2 to the third power is equal to 8. Okay, hopefully that's a decent review. So with your work during this unit, we're going to be talking about rules of exponents when you're multiplying. Excuse me. So this one here is kind of like the opposite of what we just did. We just evaluated the exponent. Now we're going to rewind. We're going to reverse back, and we're going to write this in exponent form. So one, I'm multiplying by the same number over and over and over again, right? 4. So that tells me what my base is. And remember, the exponent, that is determined by how many times a number is being multiplied. So right now I have 1, 2, 3, 4, 5 fours. So this is the same thing as 4 to the 5th power. Okay? On this particular one, we're not going to evaluate it. We're not going to actually solve it. But you easily could if you wanted to, whether writing it out or with the calculator. Okay? So, number 2. Woo! This time we have x's. How do we feel about x's? Those are also known as variables, right? They're like a placeholder for a number. We're not sure what the number is, right? So we put something else in there to hold its place, or to just to represent it. Okay? Now, with the product rule, in order to do what I'm about to do, the base has to be the same. That's a really important thing, okay? If this were an x and a y, I would not be able to do what I'm about to do, okay? So, but with the product rule, I could evaluate this or simplify it, okay? First I'm gonna expand it. It's gonna get a little worse before it gets better, okay? But what I could say here is, all right, well, this is the same. I know that x squared is the same thing as like x times x. Well, and then I'm multiplying that by, and here I've got x to the 5th power. That means I need to multiply 5 x's together. Let me make sure. 1, 2, 3, 4, 5. Good. Well, now it's an expanded form, okay? But I could simplify it because now, look, it's in this same setup. They just happen to all be x's. Well, how many x's do I have all together? 7. So this is the same thing as x to the 7th. Ooh, let me take it a step further though. Couldn't I rewrite this then as x to the 2 plus 5? Right? Which is also equal to x to the 7th. All those are the same thing. Pretty cool, right? So I can do the same thing. Uh-oh, what's going on? Sorry, I have to think backwards when I move my notebook. I'm moving my document camera too, that's why. I'll move down. There we go. That looks pretty good, doesn't it? Number 3, 2 to the 4th times 2 to the 2nd. Well, there's a few different things we can do. One, we got to notice, whew, my base is the same. That's a good thing, right? So I could rewrite this as 2 to the 4 plus 2, which is equal to 2 to the 6th. I could also write it all out. If you're not confident in doing that, if you're like, I don't see it, Miss Angel, well, then write them all out. Go 2 times 2 times 2 times 2. There's this guy. Okay, I'll do this so we can really see it. And then I'm multiplying that by 2 times 2. That's this guy. Well, how many do we have altogether being multiplied? Oh, we have 6 of them. So that gets us back to 2 to the 6th power. Okay? And to evaluate it, you would do 2 times 2 times 2 times 2 times 2 times 2. Okay? How about this one, though? Whoo! We added a new element. We have a negative number. Right? Oh, okay. Well, that's where this method is going to come in handy. All right, knowing that we can add our exponents together when our bases are the same like this, I can rewrite this as 3 to the 9th plus negative 5. But when you add a negative to a positive number like this, it's really just subtraction, right? That's a concept from 7th grade that hopefully you remember. Okay? I put some videos on your intro page reviewing that concept, so if you need it, go back and watch, okay? Well, this is the same thing as 9 minus 5. Well, what's 9 minus 5? 4. So it's the same thing as 3 to the 4th power, okay? Let's go ahead and evaluate that one. Let's do 3 times 3 times 3 times 3. That's what this one is. Okay? We've got 3 times 3 is 9. 3 times 3 is 9. Multiply those together. Yep, we get to 81. Okay? Okay. Now the other thing we could do to make this a positive, this is going to take it an even a step further. For those of you that need it, that you crave it, you're like, I got this, Miss Angel. Okay? But in order to make this a positive, we would bring it into a denominator. All right? Into a denominator. So I could rewrite this as 3 to the 9th over 3 to the 5th. Well, if I write all of that out, 3 times 3 times 3, let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9, over 3 to the 5th, oops, right? Well, 3 over 3, those cancel each other out because those are equal to 1. These all cancel, all cancel, all cancel. Once again, oh my goodness, this document here. Sorry, guys. Once again, I'm left with 3 times 3 times 3 times 3, or 3 to the 4th. Okay? So, lots of different ways to show this, which I like. I think that's a great thing. Okay, last two. We've got, we're going to simplify this one. 100 to the 8th power times 100 to the 7th power. Our base is the same, so we can add our exponents. So we've got 8 plus 7, which is equal to 100th to the 15th power. Woo! That'd be a lot of zeros, right? All right, last one. Okay, here's another one with negatives. 2 to the 5th times 2 to the negative 2. Okay, so I can rewrite this as 2 to the 5th plus negative 2, which we know is the same thing as 2 to the 5th minus 2. Okay, which is the same thing as 2 to the 3rd power. If you wanted to even go further and evaluate it, I don't think they require you to do that on your quick check, but it's good for us to practice. That's the same as 2 times 2 times 2. Well, 2 times 2 is 4, times 2 is 8. Look at all that math, just from this little itty bitty problem. Look at all that. All right, guys, I hope this helps. There were some problems from your practice, some problems from your quick check. So, as always, call me if you need help, and have a wonderful day. I'll see you in live lesson.